Hello everyone, welcome to this video. Let's start with a solution of LTC AIIMS Chemistry Unit Test number 6. Here's the first question on long-standing solution of alkali metals in liquid ammonia form metal amide because in the solutions of liquid ammonia there is metal cation, there is a solvent ammonia and there is one electron. Alright, so this decomposes to give MnH2 plus half of hydrogen gas, right? That is how. Most electronegative and least electronegative elements of group 13 are respectively boron and aluminium, because from boron to aluminium electronegativity decreases but then it begins to increase gradually. Quartz is a crystalline form of silica, so this is incorrect. Silicons are hydrophobic, yes, that is correct, because of the alkyl groups on the surface of silicons. So this is the correct answer. Coke is used as a reducing agent. Yes, carbon is used as a reducing agent where it gets oxidized to either CO or carbon dioxide. Graphite is not used as an abrasive because of its hardness. Diamond is used as an abrasive. So statement 1 is correct, but statement 2 is not. In this reaction, the oxidant and reductant are both chlorine, because this reaction is an example of disproportionation of chlorine. And disproportionation refers to the oxidation and reduction of the same species, right? 1 mole of methane contains 5 gram atoms. Yes, correct. 1 gram atom of carbon and 4 gram atom of hydrogen. Occupies 22.4 liters at STB. That is also correct. Contains 4 moles of hydrogen atom, not 2. So this is incorrect. Contains 1 mole of carbon. So yes, A, B and D. These are the correct options. C2H5I in presence of X gives C2H6 ethane. So this is basically reduction, and this cannot be this, because when an alkyl iodide reacts with zinc in ether medium, this is like Frank-Land reaction, and it's very similar to Wood's reaction where the coupling occurs. Okay, and we get N-butane in this reaction. Okay, so this cannot be the correct answer. In this N-hexane in presence of these catalysts Cr2O3, L2O3, etc., it will give you benzene. Cyclization will occur, aromatization, and in presence of AlCl3 and HCl, isomerization occurs. So N-hexane gets converted to its isomers like 2-methylpentane, 3-methylpentane, like that. So this is the correct option. 1,2-dibromoethane, guys, is this CH2Br and CH2Br. 1,2-dibromoethane when heated with ethanolic zinc. So debromination occurs, dehalogenation occurs, and you get a double bond here. So that means the compound is ethylene. So this is the correct answer. Which of the following groups is weakly deactivating but ortho and para-directing towards electrophilic substitution when attached to benzene ring? Of course, halogens. Because of the lone pair, they show plus M effect. They are electron donating, but because the minus I effect dominates, so they are slightly deactivating, right? But because they're electron donating by resonance, so the orientation of the incoming electrophile is controlled by the resonance, wherein the incoming electrophile gets attached at ortho or para position. So halogens are ortho and para directing group. Acetylene, when it reacts with excess of HCl, so it gives product A, that is ethylene chloride. So when you add 1 mole of HCl, Markovnikov doesn't really matter, right? So let us say we get this CH2 double bond CHCl, but then the addition of next H plus would be favorable on this carbon, because this would be slightly stabilized by the, again, electron donation from chlorine. So we will get this CH3 and then CHCl2. So two similar halogen on the same carbon atom, that's geminal dihalide, which are also called in the common system as ethylene dichloride, right? Alkylene halides. This is a terminal alkyne. NaNH2 is a strong base, so it will be an acid-base reaction. This would be C minus Na plus nucleophile, and this would be SN2 reaction, right? Nucleophilic substitution reaction. So wherein you would get when this will attack the bromo ethane, you will get this, right? So this is pent-2-ine, an alkyne, substituted alkyne. 2,3-dimethyl-butene, when undergoes ozonolysis, it gives product A, and then which undergoes reduction with sodium borohydride to give B. Okay, guys, so 2,3-dimethyl-butene. So we are talking about this, right? And of course, when you carry out the ozonolysis, you get acetone, and the reduction of acetone with NaBH4, it gives you isopropyl alcohol, right? So isopropyl alcohol, which we also call IPA in short, this is a secondary alcohol. Then consider the reaction. Half-life of the reaction is 50 minutes if the initial concentration is a. Guys, half-life is directly proportional to initial concentration raised to the power 1 minus n. Right, so initially half-life is 50 minutes and then it changed to 2.5 minutes. Initially the concentration was 4 and then the concentration was changed to 0.2, so it is 1 minus n, right? All right, so you solve this, guys. 1 minus n you can solve for, right? This would be 20. Likewise this would be 20, so 20 raised to power 1 is 20 raised to power 1 minus n, so of course n is 0, right? So this is a zero order reaction. 93.75% of a first order reaction is completed in 600 minutes. So time taken for 99. So such questions can be simply done is like time taken for 99.9% divided by time taken for 93.75% completion. You guys know that time as per the integrated rate expression of a first order reaction, time is 2.303 divided by rate constant and logarithm of initial concentration by final concentration. So 2.303 by rate constant, it will cancel out, right? What will remain is logarithm of initial by final. So 99.9, let's take the initial concentration as 100. 99.9 is gone, so 0.1 is left. And then logarithm of 100, 93.75 is gone, 6.25 is remaining, right? So you work out these logarithm values. It's very easy. Log 1000 is 3 and then you can simply cancel that out. Substitute the value of this as 600 minutes. You will find out the time as 1500 minutes. Okay. Consider the reaction A plus B gives product. When A is quadrupled, that means it is increased to fourfold, right? 4 times. Keeping B constant, the rate of reaction becomes 4 times again. So there is direct dependence. Order is 1. It is reduced, right? And then when B is tripled, keeping A constant, then the rate of reaction triples. So again, direct dependence. So the overall order of the reaction is 2. Individual orders of 1. Benzene with concentrate H2SO4 and SO3, this is sulfonation. You get sulfonic acid, benzene sulfonic acid, like this. And when you react it with aqueous NaOH, this is a nucleophilic substitution reaction, nucleophilic aromatic substitution reaction. So hydroxide attacks, sulfonate is SO3H minus. It's a very excellent leaving group. It just leaves and you get phenol. Of course, you will have to do the acidification also. Aniline, we are carrying out the diazotization. It is giving us the diazonium salt. And how do we get phenol from diazonium salt? By reacting it with either dilute acids or just letting it come to room temperature, right? Because diazonium salts are unstable at room temperature, so they spontaneously decompose to phenol. So this is the correct answer. In this CH3I C2H H5O minus Na. So of course this is an ether SN2 reaction, CH3O CH2 CH3. Now when you react it with HI, of course, because there is not a tertiary alkyl group which can give stable carbocation, so SN1 mechanism is ruled out. So of course SN2 mechanism will occur. In SN2 mechanism, the nucleophile iodide will attack the less sterically hindered carbon, which is of course CH3. So the answer would be CH3I and CH3CH2OH. So this is the correct answer. Acetaldehyde is CH3C double bond ONH. When it reacts with ethyl magnesium bromide is CH3CH2 MgBr. So this is nucleophilic addition reaction, guys. All right, it's simple, the mechanism. So it is CH3CHO minus MgBr plus and then CH2CH3 and followed by hydrolysis. It will give you alcohol, so butane 2-ol. So this will be the product. Regarding iodoform, the incorrect statement is this because it is yellow. Which one of the following compounds cannot give turbidity at room temperature with Lucas? So you should know that in Lucas test, tertiary haloalkanes reacts the fastest, right? Tertiary alcohols react the fastest, but then primary they don't, right? So this is secondary, this is tertiary, this is primary, this is secondary. So which will react the slowest? Primary, of course, this one. So this will not give turbidity at room temperature with Lucas reagent. The alcohol which gives alkene when heated with copper at 573 Kelvin is tertiary alcohol because they cannot be oxidized. So this is a tertiary alcohol. At 300 Kelvin, activation energies of 4 reactions are given. Rate constant will be highest. So higher the activation energy, lower will be the rate of reaction, guys. Remember that. So first reaction has the least activation energy, it will be fastest. Standard reduction potential values are given and all are reduction potential values, right? So from the above data, identify the best reducing agent. Remember guys, oxidizing strength is proportional to the reduction potential. So of course, reducing strength would be inversely proportional. So the lowest value is what we are talking about here, which is for magnesium. So that is the correct answer. You have to calculate the MF because concentration of 1 molar, you don't have to employ the Nernst equation. You can directly find it out. E naught cell is equal to E naught cathode minus anode. Cathode is iron, whose value is minus 0.44 volt, minus anode, which is this sodium, and it is minus 2.71. So you can calculate, it will come out to be plus 2.27 volt. A specific conductance of 0.01 molar, concentration is given, kappa is given, and molar conductance is to be calculated. So it's simple guys, it's kappa into 1000 divided by concentration. Substitute the values, you'll find out the answer to be 0.001. Molar conductance at infinite dilution for ammonium chloride is X, sodium hydroxide it is Y, and for sodium chloride it is Z. Now I want to find out the molar conductance at infinite dilution for ammonium hydroxide. So basically I need two ions, which is ammonium, I'll get it from X, hydroxide I'll get it from NaOH, so plus Y, but then I don't need the other two ions, so I'll minus subtract Z from it. So X plus Y minus Z will be the correct answer. 1 Faraday of electricity can deposit 1 gram equivalent of a substance. Remember guys, okay? So the maximum amount of substance would be, so molten NaCl at cathode would be Na plus, so it would be 23 by 1. For aqueous copper sulfate, it would be copper, so it is 63 by 2, 63.5 by 2, and then aqueous silver nitrate, it is Ag plus, so which is 108 by 1. Guys, I am calculating the gram equivalent weight, okay? How do we calculate the gram equivalent weight? Molar mass divided by N factor. Molten MgCl2, which is basically Mg2 plus, so 24.3 divided by 2. So of course, it's maximum for what? Silver. That is the correct answer. The 15th group element with the highest melting point is arsenic. Stable trihalide of nitrogen is NF3 because of strong NF bond. Others are either unstable or explosive. Nitrogen is not liberated in the thermal decomposition of ammonium nitrate because it gives N2O, nitrous oxide plus water, right? All other give nitrogen as one of the products. Which one of the following oxide is acidic, colored, and paramagnetic? It's very simple to figure out, guys. NO is paramagnetic and NO2 is paramagnetic. Others are diamagnetic, so they are ruled out. Now, which is colored? So, of course, NO2 is brown colored gas and it is acidic. And you guys would be knowing that NO and N2O, these are neutral gases. So, this is also ruled out. So, the correct answer is this one. And two gases liberated in the following reaction. So, you guys should learn that whenever concentrated HNO3 reacts, then the product of nitric acid is NO2. All right. NO2 gas with copper dilute HNO3, it gives NO. With zinc, it gives us N2O. So that is the correct answer. Phosphonic acid is H3PO3, right? Remember these common names. Thermally most stable fluoride and chloride of first group elements are respectively this, because fluorides become less stable, while chloride, because of its larger size, the chlorides become more stable down the road. So this is the reason for this answer. The oxo, an ion of S block element which cannot exist at room temperature, is X. The oxo, an ion of S block element which can exist in nitrous salt. So this is the correct answer because beryllium carbonate can only exist in atmosphere of carbon dioxide, not under normal conditions, and barium nitrate occurs as anhydrous salt. That is the correct answer. Oxidation state of sulfur atoms in sodium tetracyanide, guys. Remember this. This would be O minus, S double bond O, S double bond O. All right. So you can find out the oxidation numbers 1, 2, 3, 4, 5. So this is plus 5, this is plus 5, and this is 0, 0. So this is the correct set of oxidation numbers. X grams of sodium bicarbonate liberated sufficient carbon dioxide which can completely oxidize 36 gram of coke. So of course sodium bicarbonate is NaCO3. So when you heat it, it gives you Na2CO3 plus H2O plus CO2. Right now I am reacting this liberated carbon dioxide with carbon to give CO2, of course, right? So I 36 gram of carbon I need 36 gram of carbon. Okay, I need to oxidize, which is 3 moles. So I need 3 moles of oxygen. So basically 3 moles of carbon dioxide. So of course, which is twice. So you can calculate, right? Okay, so you can calculate the amount of NHCO3, which will come out to be 504 gram. Then try out this question. CH triple bond CH dilute is to score HgSO4. So this is acetylene. We are carrying out the hydration. This gives us aldehyde. Remember guys, acetylene is the only alkyne that gives aldehyde in hydration reaction, right? Now I'm carrying out the reduction. So reduction gives us CH3CH2OH alcohol, and then carrying out the oxidation with PCC. PCC oxidizes primary alcohol to aldehyde. So again we get acetaldehyde. Okay. Then consider this reaction. A gives to B. Initially the pressure is P naught. Let us say the change in pressure is minus X. So this would be plus X. So at time T, the total pressure would be P minus X plus 2X, which would be P naught plus X. But this is equal to the total pressure PT. So X would be PT minus P naught. Now the integrated expression would be K is equal to this term, 2.333 by T log initial pressure, which is P naught, divided by pressure of the reactant at time T, which is P naught minus X, and X is PT minus P naught. So P naught divided by 2P naught minus PT. So this is the correct answer, guys. The hydroxy compound which converts to halo compound just by shaking with HCl is this, because it is tertiary and most reactive. Phenol when treated with acidified potassium dichromate, sodium dichromate, it converts into parabenzoquinone. This is the product, guys. Dark colored solids, and number of pi bonds is 4. Aniline in diazotization will give you benzene diazonium chloride, N2 plus Cl minus, and this is Cu2 Cl2 HCl. So this will give you chlorobenzene, right? And chlorobenzene, when you react it with sodium and diether, so this phytic reaction, you will get biphenyl or diphenyl. This is the correct answer. Toluene reacts with 1 mole of bromine at 773. Because there is no Lewis acid catalyst, so this cannot be electrophilic aromatic substitution. It will be free radical substitution, right? So one of the hydrogen atoms of the methyl group in toluene gets replaced by bromine. So we get benzyl bromide, and when you hydrolyze it, this compound with NaOH, you get benzyl alcohol. This, right? All the following ethers give 2 moles of halo compounds when heated with excess of conc HI, except this one, because remember phenyl ethers always undergo cleavage at this site because of the partial double bond character here. So phenol is always one of the products. Remember that. Reduction potential, guys, E reduction is minus 0.059 times pH. Now you guys know that pH itself is minus log H plus minus minus plus. So 0.059 I can say log H plus. So reduction potential is directly proportional to the concentration of H plus ion. So this is the correct answer. During the discharge of lead storage battery for 2 farad of electricity to be generated, number of moles of sulfuric acid. For this you should know the net reaction which happens in lead acid battery, which is Pb plus PbO2 plus 2H2SO4, and then what does it give you? It gives you 2 PbSO4, and then you can figure out what is left, 2H2, right? So for 2 farad of electricity, 2 moles of H2SO4. That's the correct answer. Which one of the following hydride has the highest melting point ammonia? Because of hydrogen bonding, which is not there in the other 3. Regarding white phosphorus, the correct statement, it is poisonous. White phosphorus is poisonous. Yes, it is the correct statement. It does not show chemiluminescence. No, it shows chemiluminescence. Luminescence, so this is incorrect. It is soluble in water. No, it is not soluble in water. This is incorrect. It is insoluble in carbon sulfide. No, it is soluble in carbon sulfide. So this is only the statement that is correct. All right, guys. Thank you.